All right, here's one of these nice dreaded order the magnitude of something problems. So we have a meter stick that's rotating below about an axis marked with the dot at 20 centimeters. So we're rotating about our axis right here. 5 different forces act on the stick, each one labeled as they're shown. If each of the forces is the same force, we want to rank according to the torques that they provide. Well, we know that the torque is given by D cross F, where that cross product can be rewritten as the torque is going to be dF sine of the angle between the two. And I'm going to actually mark this as dr, knowing that it's the angle between the displacement vector and the force vector. It should be an F. So I look at these. In all the cases, my force is the same, but I have to figure out what happens to my d, what happens to my theta. So I'm going to look from least to greatest. I'm going to look at force 2. Force 2 has a radius 2 of 0 centimeters. Force 2 is attached to the axis of rotation, so it has a distance of 0. So I know that force 2 is going to be my lowest magnitude. So that means 2 and 5 tie, 2 and 5 tie. I know it can't be A and I know it can't be B, because that's force 1. Force 1 has some distance to it. It's got some torque. Tau 2 is equal to 0. I'm going to look at force 5. Force 5 is actually an interesting case. Force 5 points in the x direction. Right? This has a thing in the x direction. I also know that to get to force 5, I have a radius 5. And radius 5 also points in the x direction. So the angle between R5 and F5, the angle is going to be equal to 0. So the sine of the angle is 0. So force 5 also is a torque of 0. So I know that 2 and 5 have to be the same torque because they have the same 0 value. Let's look at 1 and 3. 1 and 3 both are a distance of 20 centimeters away. They're both perpendicular to the radius that they would be at. They both have the same force. They point in different directions, so one's going to be a positive, one's going to be a minus torque, but they have the same magnitude. So torque of 3 is equal to the torque of 1 in magnitude. So in that case, I can look at this and go, well, 1 and 3 can't be right. E has to be my correct answer because 1 and 3 tie. And let's just make sure that a torque due to 4 fits in the middle. 3 points straight up. 4 is at the same location but points at an angle not 90 degrees. It's less than 90 degrees. So that means torque due to force 4 is going to be less than torque due to force 3. So force 4 has some value. It's not 0. Has some value, but it's not as max as 1 and 3 are. So we get the right answer.